All right, we're on 7.3. We're going to look at factoring. So we've been multiplying polynomials and distributing, right? Do you remember what factoring is? Did a little bit of a while back, I think. That's one, yeah, that's one avenue of factoring, yeah. But do you remember when we first talked about the distributive property? You remember how it also worked in reverse? Like all the stuff we did yesterday, we multiplied through, we can undo that, right? That's called factoring, okay? So they kind of give the dictionary definition, both verb and noun of factor, right? Like factor can be a verb, which basically means to undo multiplying, undo distributing, right? So it is the opposite of multiplying / distributing. And then after you factor something, you will have what are called the factors of the thing you factor. Okay, so it's also a noun. Right? Anyway, so exercise 1. We're looking at an expression here: 6x squared plus 15x. You all heard the term the greatest common factor, have you?
Yeah.
At some point? Okay. And that's just the largest thing that can be divided out of two or more things, right? Like they share in common, you can divide it out. So what they want us to do is take these two things separately, 16x squared and 15x, and find their greatest common factor. So let's just completely factor out every factor that multiplies together to get 6x squared. So let's start with the 6. Give me a couple of numbers that multiply to 6. Okay, so we can rewrite this as 2 times 3 times what? X. Break it
And
open.
then again.
Okay, that's what I'm getting at. All right, so now let's do the 15x. 3 times 5 times, okay. Now, we've listed the factors of both of those, right? We've factored them, and so now we have the factors of them, right? So what factors do they have in common? There's a 3 in both, and a single x factor in both, right? So what would the greatest common factor of these two terms be? The GCF between both of those, greatest common factor, is 3x. Simple enough, right? You've done this before, haven't you? Yeah, okay. So now knowing this, right, if I divide 3x out of 6x squared, what's left? 2x. If I divide 3x out of 15x, what's left? Just 5, right? Okay? So let's rewrite this sum here. This 6x squared plus 15x in factored form. What was the GCF? Okay, so we're going to divide out a 3x from both of those. So there's my 3x, parentheses. And what is 6x squared divided by 3x? 2x, right? And then 15x divided by 3x plus 5. And there it is, factor. Okay? So yesterday we were going the other way, weren't we? Yesterday we were starting with something like this and doing what? So just think, don't do it. I know what happens here. Like when we get to this section, after we've done everything we did yesterday, you kids will get this factored out, and then for some reason your next line will be to distribute this, and then right back where you started. No. But if we were to, what's 3x times 2x? There's my 6x squared, right? And 3x times 5 is, that's what we did yesterday, okay? We're just going the opposite way now, okay? What do they want to do in C? They want to so what they want to do is plug in 2 to both of these things here and see if we get the same result, right? In other words, are they equivalent? Yeah? So now we'll do that real quick. So 6x squared, but x is 2. So it'd be 6 times 2 squared plus 15 times 2, right? What's 2 squared here? And then 6 times 4 is 24, plus, what's this? 30, which of course equals what? 54. Let's check the factored version of this. So 3 times 2 times 2 times 2, right? Plus 5. This out here gives us what? That's 6 times 4 plus 5, right? Which is 6 times what? Come on, yeah, 9, which is 54, right? So if we factor correctly, they will be equivalent. And that is why we use equal signs, right? Just to look at some of your homework when it comes in, it doesn't look like the work that I show you here, right? You don't have the equal signs. I'm going to start taking off for that. It's important. Yeah, I think I'm going to.
Oh dear.
I'm pretty sure. Oh dear, just put equal signs in. Like some of the stuff you write when you're home with the work, have you ever seen me do it that way? But you do it anyway? It baffles me sometimes. But anyway, let's move on. Let's see. So, for each of the following sets of monomials, let's identify the GCF of each, okay? And we'll start out maybe with the first few, breaking each one of them up separately, like we did up here. And then we won't really have to do that, right? So, yeah, the 12x to the cubed, we can rewrite as 4 times 3 times x times x times x, right? What about the 18x, people? 9 times 2, but don't I want to try and get a common factor? 6, how about 6 times 3? Yeah? Actually, couldn't I do 3 times 2 times 3? Let's do it this way. Wait, you said 9 times 2, right?
No, for the other one, do 6 times 2. And your greatest common factor would be 6.
Yeah.
For number 6 times 2 for 12. 4 times.
Okay. We could do that, right? Let's break it up all the way. Wait a minute. Let's get the prime factors. Let's do that way. So the 4 we could do 2 times 3 times x times x times x. Yeah? So this way we don't have to even mess around. Now how about the 18? Instead of 9 times 2, how about the 9? Could be what? 3 times 3 times 2 times x. Right? So what are the common factors now?
3.
That's it. So we have a
2 and 3. All of them are
3 and a 2 and an x and a 3 and a 2 and an x. So what is our GCF?
3, 2,
6x. Get the idea? All right. Mm-hmm. Yeah, 2 times 2 is 4, times 3 is 12, right? So I just broke the 12 into its factors. And I broke x cubed into its factors, right? So let's do that for part B. So 5x to the 4th. Yeah, I'm not even going to bother with 1, right? Does 1 even help us? No. So actually, at some point later on, it kind of will. So generally, factoring out a 1 doesn't help us, except in one instance when we get to it a little bit later. But anyway, right now it won't. So it'll be 5x times x times x times x, and then what?
5 times x.
Okay. And so we have a 5 and a couple of x terms, right? The biggest we can get out of both. So what's our GCF? It's going to be 5x squared. That's the biggest factor you can divide out of both of those terms. Okay? Let's try part C. I don't want to bother breaking this up. Okay? So let's just write GCF equals. Let's start with the 21 and the 14. Yeah, I don't want to even break it up. What's the greatest common factor? Yeah, okay. So 7. Right, now between the x squared and the x to the first, what's the greatest common factor there? Just the x is the biggest I can divide out of both, right? Now between y to the fifth and y to the seventh, what's the largest factor of y I can get out of both? Y to the what? The fifth is the biggest one I can get out of both, so there you go. Okay? Get the hang of it? Okay, you guys on your own now do D, E, and F. Let's see how we do. Now, what's the GCF for part D, you guys? GCF equals 8x. Good on that? Well, start with the numbers. So just think of the numbers themselves, Hannah. Between just 24 and 16 and 8. What's the largest number you can divide out of all three of those? Why not 8? You can divide an 8 out, right? And now look, between the x to the third, x squared, and x to the first, what's the largest x factor you can divide out of all of them? Just x to the first. That's it. And you're done. Yeah, that's what I just wrote, x to the first. Oh, the biggest one you can get out of all of them. So in other words, you have to kind of look at the smallest one, right? Like, yeah, that's the biggest one of them all. I didn't ask what's the biggest of them all. I said, what's the largest factor of x you can divide out of all of them at the same time? So I can't get an x cubed out of just an x to the first. But I can get an x to the first out of all three of them, right? Okay, all right. So how about an E? GCF is what? GCF would be 4x, right? And the last one, F? Good. GCF equals 9xy. The biggest I can divide out of all three of those terms. Okay. All right, let's move to the other side here. On the page. So now we're going to really be doing the opposite of what we did yesterday. Yesterday we were distributing and combining like terms, right? Okay. So now we're going to do the reverse of distributive property. Well, the distributive property is multiplying, so the reverse of that would be what? Dividing out the factors, so factoring, right? So let's look at 6x squared. What is the GCF for both of these terms? 2x, right? So that's what I can factor out of both of them, right? So this would equal 2x, and then my parentheses, right? What's 6x squared divided by, what's 6 divided by 2? 3, and then x squared divided by x. X, okay, plus 10 divided by 2. And then the x divided by x just cancels out, right? It's just 1. All right? So just think of it that yesterday, if I distribute this 2x, wouldn't I have the 6x squared plus 10x? Going the opposite way. All right? I'll work one more with you. 3x minus 24. What is the GCF of both of those?
3.
Just 3, right? Can I get an x out of either one of them? Oh, one of them I can, but I can't get it out of both of them, right? So it would just be 3. So equals 3 times what's left in the parentheses. X 8. Okay, getting the hang of it? All right. Why don't you guys work through the rest of these on your own? Okay? And yeah, I don't need you to write GCF equals up here unless you think it helps you, right? If you can do it without writing it up separately like that, just go ahead and do it, all right? How many got that for C? One kid, two, that's it, three. All right. How many got that for C? Okay. If you didn't get that, ask me a question about it. You made a plus sign? But you got the numbers, right? Okay. Dial in on those plus and minus, that's important, right? But as long as you get the GCF, that's good. And then the factor. How about that for D? How many got that? Raise your hand. Factored out of 4. You're left with x squared plus 2x plus 6. One person? That's fine. Not necessary, but it's fine. You got that? Okay. But so, like, you guys that didn't get it, did you like have a 4x out in front, maybe? A 2, okay. Common 2 would be a common factor, but remember, it's the greatest common factor, right? And somebody said you had a 4x out here, but look at the, right? You can't get the x out of just the 24, right? Okay. All right, keep working. So maybe showing you those, we fixed a couple things in your head. About that for E, guys. Yeah? You don't have your hand up? What, you got that? Serenity? What did you have?
The same thing, just I put X instead of 1.
Oh, right. Well, yeah, remember, like once you pull that out, you're dividing each of these by that thing, right? So 2x divided by, anything divided by itself is what? 1, right? Yeah, okay. After, let's see. Oh, 5. About that? Yeah, good. But what? Oh, you gotta be careful, right? Because once you pull out that factor, like to get the factor, you have to divide to get the factor, right? And then when you divide, you put the result back in the parentheses. Okay? Did you guys do the last 3 yet? You need another minute.
Yeah, no, I did it.
We'll do the last one. Do it. Yeah. You can.
Yeah.
G, how about this one? Again, you could not get an X out of all 3 of them, right? Because the last one doesn't even have an X on it, right? And let's see, H, you can get a 2 of those and an X squared, right? So 2x squared is the GCF. What would that leave us with?
4x.
No, why negative?
4x minus 1.
4x squared minus 1. Not the same thing, wildly different. You're not in your world, you're in my world.
Wait, I put the negative.
Wheeler, get something for the last one? Well, did you get a TCF at least? Okay, well, H part of it. Now, how about the variable? There you go, okay. You tell me you couldn't do it.
For the last one, I did negative, and there was a minus sign for 2.
You did what now?
Negative.
Negative what?
2.
Is the GCF?
Yeah, it's there was a minus sign. She's on the H.
Oh, here?
Yeah, but it's not
Okay, so if you put negative, so pay attention to this, right? Because that is, actually, listen, because that's a thing that we might have to end up doing later. Generally, we won't take out the negative factor. If you had negative 2x squared out here, what did you have here? Negative 4x squared plus 1. So if you factored out a negative with them, what you did was just switch the signs of the things inside. We don't need to do that now, but later on, we might find that to be a useful trick for something else. So, but right now, don't do that. Why would that be? Is that hard? Really?
Not that way, the other way.
Her way? You know, like what? Look, sometimes you might need to. That's hard. This would be an undue burden to you. Oh, you're right. Oh, jeez.
I got I.
You gotta get me a sling.
For G, I didn't use 10 as an easy.
You didn't use what?
10.
What did you use?
I used 5.
Okay, 5 is a common factor. That's true, right? But it's greatest common factor. 5 is a common factor for all of those. Yeah, that's true. But you got to get the greatest common factor out. Okay? Does that make sense? Okay. And so what did we have left here when we factored out this 8x?
X squared plus 4 minus 4x. How's he get 3? So 8 divided by 8.
Minus what? 4, right?
Minus 4x.
Why x? Yeah. We divided the x out of that term, right? Okay? All right, so you're kind of getting this. So now that you're kind of barely getting this, let's throw a big twist on it. Nah. Right, so you notice that all these terms are like monomial terms, right, that we're factoring out. We can factor out any, like binomial, trinomial terms, as long as they're kind of wrapped together in parentheses. They can act like a single monomial term, right? It's like taking two things and wrapping it in duct tape, and now you have one thing, right? That makes sense, right? So let's look at this last exercise, because this all, it's going to work the same. Okay, let me try. So here we have a binomial times a binomial plus binomial times, but these parentheses, right? Forget that there's a binomial there. Just at the moment, treat it, because it's wrapped in parentheses, like each one of these is one term on its own. Okay, well, hold on. So, see up here, let me find a term plus term here, okay? 6x squared is a term, everybody looking? 10x is a term, right? The terms are separated by plus or minus, right? So, if we look down here, you see that plus sign here outside the parentheses? That makes this thing is its own term, and that thing is its own term, just like the one I pointed to at the top of the page, isn't it? Right? And if you're looking at factors, factors are the things that you multiply together to make that term, right? Like if the term was 6, it would be 2 times 3, wouldn't it? Isn't this kind of like my 2 times 3? Right? Okay. So these things here, this x plus 5 and x minus 1 are factors of this first term. This x plus 5 and 2x minus 3 are factors of the second term. So what is the factor that both of these terms have in common? That x plus 5 is the common factor, just like we did up top, right? Forget that it's a binomial, right? It's wrapped in parentheses, so it's like one thing, right? So we can factor out an x plus 5. Watch. So here it is. Here's my x plus 5. And so what gets left inside the parentheses now? So I have x minus 1 plus what? 2x minus 3. You see how it's just like what we did up top? You just got things wrapped in duct tape here. to act like one thing, that's all.
Why
Oh. Why what?
the x negative one, or x minus one, and the plus two x minus three, and
You're crossing out your thing.
She's asking why they're in parentheses inside?
no, but like those instead of the other x.
How does that do great?
In here. This is this, see that both of these terms have this greatest common factor, so it comes out. And then you do just, so when I divide the whole term by that common factor, I'm left in this one with x plus 1. I divide this term by that common factor, I'm just left with the 2x minus 3. Now, I really didn't need parentheses around each one of these, because what's in front of this parentheses inside here? And in this one? Right, so really, it's x plus 5 times just x minus 1 plus 2x minus 3, right? And can we simplify this a little bit more? X plus 5 times what, guys? 3x
3x negative 4.
minus 4. Negative 1 minus 3. Okay? You guys see how I connected all this with equal? Because I intend every single one of these things to be equal to the top line. Cammy?
The 3x minus 4,
What's x plus 2? I'm just combining like terms. What's x plus 2x? And the negative 1 minus 3 is minus 1. That's all. Okay. So you guys try this one. So let's take a look. Do we have, again, two terms here? Yep. Now, between those two terms, do they have a factor in common?
Yes.
What is it? 2x minus 1, right? So why don't you guys factor out that 2x minus 1, and then parentheses what's left inside. And now be careful with this one. There's a slight little difference between the two. Take a minute. Did you got a final answer? What do you have? What do you have?
2x minus 1 and then x plus 10.
Yeah. Anybody else get that?
I got x plus 4. I got negative 3 or negative 3.
It's because there's a negative in between, so it's like negative 1. We have to add that to that.
So let's go through. So when I divide the 2x minus 1 out of this term, what's left? 2x plus 7. With a positive 1 in front, right? Now be careful. Minus. What's left in the second term? Okay, this is why I told you to be a little careful, right? Because to get rid of these parentheses, these are fine. What do I have to do here?
You have to
Distribute that negative 1 in front of it, right? That changes things, doesn't it?
Yeah, I didn't know if I was going to break or not.
Well, you trusted your instincts, right? So this is just simply 2x plus 7. And then what? Minus x plus 3. Right? Negative times a negative? Now we combine like terms. 2x minus 1. We get 2x minus x is x. 7 plus 3, 10. Where's the 4? 7 plus 3 is 10. Yeah, why? Look, because remember, this is a negative, I'll do it in a different color. That's a negative 1 in front of there, right? And when you distribute it, it changes the sign of everything inside. Okay? You got me?
Yeah.
Think you got kind of a grip on it? Okay, well,